Hello, everyone. My name is Fangyuan Cai, and I am a master student of ECE, and uh, my project is to evaluate different intelligent algorithms for short task classification. And first of all, I have to talk something about my purpose. So, with the rapid development of information technology, of course, of the machine learning and deep learning method, so we have more and more machine learning methods for task classification, and also there are a large amount of information and chaotic organization of online news, maybe just a mess. So we can use our machine learning or deep learning method to classification to classify this news, and so we can search for each category to find some special news. And so so next is our experiments. So first we have to process our data. So our data is downloaded from the Sogo CS, their website, and the original data is like the left one. The original data is like the left one. It was, as we can say, it was in JBK file. It is a JBK file. So in order to manipulate the data, we can just transfer it to JSON file. I'm sorry. We can transfer it to JSON file like the right one, and so we can we can just put it in dictionary, just like we're searching for URL, and it will output this. And if we are searching for the content, for the information, for the text content of the news, and like this. So finally, we have to extract useful data for training. As we can see, uh, the the data we download uh, is not very useful for our training. It have many different lengths and many different kind of categories. And after calculate, we get 15. We can get 15 labels. However, we are missing the label 8 and label 11. They have no data in the data set. So uh, all of the data we and there are very less label 14 and label 15, very less. So we can just remove this data, and for the remaining data we can use 2000 of each label as our training set, and then as our all data set we can uh, for each label we need 2000 data, as we can say. So uh, after we extract the data, all the data set, we can we read the data and found their length is very uneven. So we just extract the top 100 word of the news, of each news, with its title. As we know, the title of the news always contain lots of information there. So these steps we can successfully process our data, and then we can input our data to our model. So for the and we have four machine learning method which is like the naive Bayes and KNN SVM. And we also have a method named word2vec, which can transfer the which can transfer each word to vector. It is published by Google, and we already have a pre-trained model from the internet. So we can combination the SVM with the word2vec. So the combination is mostly like we can easily summing the word vector of words in word2vec and averaging to obtain the semantic vector of the entire sentence. And although this method seems to be naive, but I think but first of all, but sometimes it works. So, and for the deep learning method, we choose the CNN and LSTM, and this tool is very good for the test classification. It is widely used in test classification, and then the very easy MLP and the combination with word2vec. And the combination is most likely we can replace the embedding layer of the CNN and LSTM to the word2vec vector. And after the experiment, we can get the final result like this. So for the CNN, we got 81% and with the original method, and 85% with combination with word2vec. And LSTM is original is 70%, and when in combination with word2vec is 82%. So because our data is very less, as we can know, we extract just 2,000 data from each category, and the total number is very small errors. So so there are some of the overfitting issue in the original model. So after we import the pre-trained model of word2vec, it contains some information of the other data set. So it just release some pressure of overfitting. But the most thing impressed me is the result of MLP. Although it's very naive it's a very naive deep learning method. It's very easy neural network. So maybe because our data set is very simple and our task is very simple, it got 86% of the accuracy. And this is and the training time is very less. It's quite less than CNN and LSTM. So it performs very well. And for the next one is for non-machine learning. Non-deep learning method is just like naive Bayes. It got 85%, which is it's very high. Not higher than the combination of CNN and word2vec, but it's already higher than LSTM, which is very impressed me. But CNN is not for the task classification. It only gets 31%, but the combination of SVM, it gets a good result. It just it's also raised to the 84, 85. So it also can used in this method in this problem. So the conclusion is that the import of the pre-trained word2 model will bring benefit to our training. So it first indirectly introduce external training data to prevent overfitting. And second, it reduces the number of parameters that need to be trained and improve training efficiency of LSTM and CNN. For then the number of parameters that the LSTM needs to train is much smaller than the CNN, but the training time is longer than the CNN. CNN has always performed very well on classification problems, whether it is imaging, images, or text. And if you want to make sure use of the advantage of LSTM, you must first ensure the amount of training data, combination data. And then the method of summing up the word vector of words in word2vec and averaging to obtain the semantic vector of the entire sentence seems to be naive, but sometimes it's work. And finally, there are many machine learning methods. The specific method to choosing depends on the scale of the data set and the complexity of the problem itself. So for problems with general complex, a seeming simple method may be the best. That's all. Thank you.